Hello, friends. Today we have AI for the perceptive. M is for multimodality. Welcome back to the AI A to Z series. I'm Dr. Sonali Tamhankar. When we watch a video like this, we don't just process words. We take in images and slides. We hear the speaker's voice and we read their facial expressions. If the speaker has an accent we are less familiar with, we might turn on subtitles. As humans, we naturally integrate information from different modalities to form meaning video, audio, text, and more. Like we understand that the word tree and a picture of one stand for the same thing. There are many applications where we would want AI systems to do the same, to take in different kinds of inputs and sometimes produce outputs in different kinds as well. In multimodal AI, the challenge is to align these different signals into a shared representation that supports a coherent understanding of the world. So, as a species, we humans have our five senses, but many more are possible. Snapdragon plants can hear the buzzing of bees and respond by increasing the sugar concentration of nectar. Dogs can smell and hear far better than humans. Birds can navigate using Earth's magnetic field, and bats can echolocate using sound waves. So we could design sensors that like many different kinds of sensors and feed all of that signal to AI for analysis. Multimodality doesn't just have to mean reproducing what humans can do. So, one such system is already driving around in cities like San Francisco, the autonomous Waymo cars. Their sensors go beyond human perception. There are LiDAR, camera, and radar systems. The LiDAR system, it's sending laser pulses and measuring the time it takes them to bounce back, mapping the world around the car, much like bats do. The radar system can measure speeds of cars and see through heavy rain or fog. By combining these multimodal inputs, the car has a precise representation of the world which it needs to drive safely and autonomously. So, how are these multimodal inputs combined? We already talked about word embeddings, how a word like tree can be represented as a vector, and how words like bark or leaf might have somewhat similar embedding vectors because they tend to occur together. But what happens when the input isn't only text? Do you just put pixels and tokens next to each other to generate a multimodal representation? So there are different possible approaches, roughly characterized as early fusion, intermediate fusion, and late fusion. The multimodal alignment is often learned using techniques like contrastive objectives or cross attention so that the related inputs from different modalities end up close in the representation space. For example, Meta's VLJPA model introduced in late 2025 explicitly emphasizes learning joint embeddings directly in an abstract representation space rather than constantly predicting tokens. Okay, a very unscientific analogy for early fusion might be high school sweethearts who are kind of almost discovering their identity together. So, in this approach, you do concatenate or otherwise combine multimodal inputs in the early stages. This is computationally expensive because the vectors get big. During training, sometimes data from one modality is masked or hidden so that each component can function on their own if needed. Okay. Then intermediate fusion is where you process each modality separately up to a point before merging them. Like two individuals meeting as adults, but then spending some time together, maybe getting a dog. And so the later layers here use merged representations. Late fusion is like a couple meeting at the altar. So, an image and a piece of text may be processed completely independently and then only combined in the final layers. This has an advantage that we could swap out the vision module for an improved version without having to retrain the whole system. On the other hand, such a system might miss some things. For example, I'm in Seattle and this is January, so I might look outside and say great weather, but inwardly roll my eyes. If the image and the text is being processed entirely independently till the end, a model might struggle to recognize the sarcasm. So, a lot of the state of the art systems use intermediate fusion, but it'll be hard to argue that one is universally better. It depends on the use case. So, just for fun, you can check out the Stroop effect, where we get a conflicting multimodal input like the word blue written in green. The brain is fascinating. We have different lobes that process different kinds of inputs, and there is also some earlier fusion happening in ancient parts of the brain, like the superior colliculus. Okay, so we saw that the world is multimodal, and applications like Waymo cars process interesting multimodal data, and combining multimodal data into coherent representation space is complex. Incidentally, multimodal models are often denoted as MLLMs, so multimodal large language models, even though they're not just language models. So many commercial models today are multimodal, a fact that I've heavily relied on to generate images for this series. So thank you, Gemini and ChatGPT. So let's conclude today by talking about healthcare. Healthcare data is naturally multimodal. There are scans, patient notes, lab reports, genomic sequencing, and more. So I'll link an article below on multimodal large language models in healthcare, applications, challenges, and future outlook. So this article is from September 2024 and talks about many different aspects like benchmarks, explainability, interoperability, and regulatory frameworks. An example of multimodal healthcare model would be MedGemini, which can process 3D scans and surgical video feeds and genomics data simultaneously. So this is a very active field. ChatGPT Health just came out in January 2026 as I record this, where you can connect data from medical records and supported apps. So the world is multimodal and AI has to reflect this. I hope you enjoyed our topic today. See you tomorrow with neurosymbolic AI to discuss ways to ground neural networks using a robust deterministic framework. So thank you for going on this AI A to Z journey with me and have a nice day. Bye.